KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
NEET, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
Hello students, we are discussing trigonometric functions concept. Okay, next concept in this topic is domain and range of trigonometric functions. Domain and range of trigonometric functions. Okay, but what is domain of a function? What is domain of a function? What is range of a function? Already we discussed domain of a function means what values we can give for the variable. Okay, in sin x, cos x, tan x, cosecant x, secant x, cot x. Now what values we can give for x, that comes under domain. Okay, by giving different values for x, what is corresponding function is giving in return, that comes under range. Okay, here trigonometric function sin x, it is defined for all real numbers. Sin x is defined for all real numbers. Sin is defined for all real numbers. So domain of the function is all real numbers. Domain of the function is all real numbers. Also we know that range of sin x, range of sin x is closed interval -1 to closed interval 1. Okay, so sin x domain is all real numbers, range is closed interval -1 to +1. Okay, closed interval -1 to closed interval +1 means -1 included, +1 included. So sin x cannot give, won't give any value more than 1 or less than -1. Okay, range of sin x is -1 to +1 closed interval, whereas domain is all real numbers. Okay, but next cos x domain and range is similar to that of sin x. Cos x domain and range is similar to that of sin x, that is cos x domain is all real numbers, it is also defined for every real number. Okay, and range is closed interval -1 to closed interval 1. Okay, now sin x and cos x domain is all real numbers, range is -1 to +1 in closed interval. Okay, next trigonometric function, that is tan x. Tan x, it is ratio of sin upon cos, ratio of sin upon cos. So tan x is defined in all the cases except when cos is 0. Tan x is what? Tan x is ratio of sin upon cos. Okay, whenever cos x is 0, tan x is not defined because something by 0 is undetermined quantity. Okay, so tan x is defined for all real numbers except when cos is 0. But cos x is 0 for odd multiples of pi by 2. Cos is 0 for odd multiples of pi by 2. Cos is 0 for odd multiples of pi by 2. So tan is defined at all real numbers except at odd multiples of pi by 2. R minus means all real numbers minus odd multiples of pi by 2. 2n plus 1 into pi by 2 where n is integer. So domain of tan is all real numbers except odd multiples of pi by 2. Okay, but range of tan x is all real numbers. Range of tan x is all real numbers. Range of tan x is all real numbers. Okay, what is the domain of tan x? Tan x is defined at all real numbers except where cos x is 0, because tan x is ratio of sin upon cos, whenever cos x is 0, tan x is not defined. Cos x is 0 when x is an odd multiple of pi by 2. Okay, so tan x is defined at all real numbers x except at odd multiples of pi by 2. So what we can write, a domain of tan x is all real numbers minus 2n plus 1 into pi by 2, odd multiples of pi by 2 where n is any integer. Okay, range is what? Range of tan x is all real numbers. Range of tan x is all real numbers. Okay, next, cosecant x. Cosecant x is what? Cosecant x is reciprocal of sine. So cosecant x is equal to 1 by sin x. So cosecant x is defined whenever sin x is non-zero. Whenever sin x is non-zero. Cosecant x is not defined whenever sin x is 0. So sin x is 0 for multiples of pi. Sin 0 is 0, sin pi is 0, sin 2 pi 0, sin 3 pi 0, sin minus pi 0, sin minus 2 pi 0. Okay, so whenever sin x is 0, cosecant x is not defined. Okay, so sin x is 0 for multiples of pi, integral multiples of pi, integral multiples of pi. So cosecant x's domain is what? All real numbers except integral multiples of pi, except integral multiples of pi. Okay, so domain of cosecant x is all real numbers minus n pi where n is integer. Okay, cosecant x is equal to, domain of cosecant x is all real numbers except n pi where n is any integer. Means cosecant x domain is all real numbers except integral multiples of pi. Okay, now what about range? Range of cosecant x is minus infinity to minus 1. Okay, minus 1 included, union 1 to infinity. Okay, 1 included. So cosecant x is either less than or equal to minus 1. Okay, means minus infinity to minus 1 and 1 to plus infinity. Okay, 1 to infinity. Okay, cosecant x range is minus infinity to minus 1, union 1 to infinity, minus 1 and 1 included. This is range of cosecant x. Next, secant x. Secant x is what? Reciprocal of cos. Secant x is equal to 1 upon cos x. So secant x is defined whenever cos x is not equal to 0. Secant x is defined whenever cos x is equal to 0. So x is all real numbers except where cos x is 0. Cos x is 0 for odd multiples of pi by 2, like cos pi by 2 0, cos 3 pi by 2 0, cos 5 pi by 2 0, or cos of minus pi by 2 0, cos of minus 3 pi by 2 0, cos of minus 5 pi by 2 0. So from all real numbers we have to remove this quantity so that secant x is defined. So secant x domain is all real numbers except odd multiples of pi by 2, 2n plus 1 into pi by 2 where n is integer. Okay, secant x is all real numbers except odd multiples of pi by 2 where odd multiples of pi by 2 n is integer, r minus 2n plus 1 into pi by 2 where n is integer. Range of secant is similar to that of cosecant, that is minus infinity to minus 1, minus 1 included, union closed interval 1 to infinity, closed interval 1 to infinity. This is range of secant x. Okay, next, cot x. Cot x is what? Cot x is cos x upon sin x. Cot x is ratio of cos upon sin. So cot x is defined whenever sin x is non-zero. Cot x is defined whenever sin x is non-zero. Okay, so cot x is not defined whenever sin x is 0. So sin x is 0 for integral multiples of pi. So sin 0 0, sin pi 0, sin 2 pi 0, sin 3 pi 0. Okay, so at x is an integral multiple of pi, then cot x is not defined. Whenever x is an integral multiple of pi, cot x is not defined. So cot x is defined whenever x is not an integral multiple of pi. So cot x domain is all real numbers except integral multiples of pi. r minus n pi where n is integer. Okay, cot x domain is all real numbers except integral multiple of pi. Okay, range of cot x is similar to tan x, that is all real numbers, all real numbers. Okay, here if you observe domain and range of trigonometric functions, sin x and cos x, domain is same, range also same. Okay, what is the domain and range of sin x and cos x? Domain is all real numbers, range is minus infinity to range is -1 to +1. Okay, closure interval -1 to +1. Okay, next if you observe tan x and secant x, these two are having same domain because tan x is sin x upon cos x, secant x is 1 upon cos x. So whenever cos x is 0, tan x and secant x not defined. Whenever cos x is 0, tan x and secant x is not defined. Okay, so domain of tan x and secant x is all real numbers except integral odd multiples of pi by 2. Odd multiples of pi by 2. 2n plus 1 into pi by 2 where n is any integer. So tan x and secant x domain same. Okay, next cosecant x and cot x. Cosecant x is 1 upon sin x, cot x is cos x upon sin x. So here whenever sin x is 0, cosecant x and cot x is not defined. Whenever sin x is 0, cosecant x and cot x is not defined. And sin x is 0 whenever x is an integral multiple of pi. So domain of cosecant x and cot x is all real numbers except integral multiples of pi. Okay, these are domain wise. Range wise, but tan x and cot x are having same range, that is all real numbers. Tan x and cot x same range, all real numbers, minus infinity to plus infinity. Okay, whereas cosecant x and secant x having same range, that is minus infinity to -1 included, union 1 to infinity, 1 included. So in between you can write like this also, cosecant x and secant x domain is all real numbers except r minus open interval -1 to open interval 1. Like that also we can write. Okay, but this is regarding domain and range of trigonometric functions. Domain and range of trigonometric functions. Okay, next. Now we will discuss how trigonometric functions changes in first quadrant, second quadrant, third quadrant and fourth quadrant. Okay, now if you observe, I think last class or before that we discussed sin x, sin 0 to 90 means 0 to pi by 2, sin x increases from 0 to 1. Okay, and pi by 2 to pi, sin x decreases from 1 to 0. Okay, anyhow in first quadrant and second quadrant, first quadrant means 0 to pi by 2 first quadrant, pi by 2 to pi second quadrant, pi to 3 pi by 2 third quadrant, 3 pi by 2 to 3 pi by 2 to 2 pi fourth quadrant. Okay, mean 0 to pi by 2 in first quadrant, sin x increases from 0 to 1. Okay, that is what it is written here. We observe that first quadrant, as x increases from 0 to pi by 2, sin x increases from 0 to 1. Okay, so in first quadrant, sin x increases from 0 to 1. In second quadrant, sin x decreases from 1 to 0. Means anyhow in first quadrant and second quadrant, sin x is positive. In first quadrant and second quadrant, sin x is positive. Okay, in first quadrant sin x increases from 0 to 1, in second quadrant sin x decreases from 1 to 0. Okay, in third quadrant sin further decreases from 0 to -1. Third quadrant sin x decreases from 0 to -1, that is the least value of sin x. Sin x minimum value is -1. Okay, after that again sin x increases from -1 to 0. Sin x increases from -1 to 0. Okay, now here what we can observe is in first quadrant and second quadrant sin x is positive. Okay, increases in first quadrant 0 to 1, okay, decreases in second quadrant from 1 to 0. So anyhow in first quadrant and second quadrant sin x is positive. In third quadrant, what is happening? In third quadrant sin x is decreasing from 0 to minus 1, further it decreases from 0 to minus 1. So in third quadrant sin x is negative. Okay, fourth quadrant from minus 1 to 0 it will increase, but it is negative. So in third quadrant and fourth quadrant sin x is negative. Sin x is negative. Now similarly we can discuss about behavior of other trigonometric functions. Now cos x, cos 0 is how much? 1. Cos pi by 2 is how much? 0. Means as x increases from 0 to pi by 2, cos x decreases from 1 to 0. As x increases from 0 to pi by 2, cos x decreases from 1 to 0. Okay. So anyhow first quadrant cos x is positive. Now further as x increases from pi by 2 to pi, in second quadrant as x increases from pi by 2 to pi, cos x further decreases from 0 to minus 1. Cos x decreases from 0 to minus 1. Okay. Now after that cos x start increasing minus 1 to 0 in third quadrant. Means as x increases from pi to 3 pi by 2, cos x increases from minus 1 to 0. Okay. Now as we move further, as x value increases from 3 pi by 2 to 2 pi, cos x increases from 0 to 1. Now if you observe here, in first quadrant and fourth quadrant, cos is positive. So cos x is positive in first and fourth quadrant. Okay. Cos is negative in second and third quadrant. Okay. Now sin x is positive in first quadrant and second quadrant. In third quadrant and fourth quadrant sin x is negative. Okay. Now cos x is positive in first and fourth quadrant, negative in second and third quadrant. Okay. Cos x is changing as x increases from 0 to pi by 2, cos x decreases from 1 to 0. Okay. Now as x increases from pi by 2 to pi, cos x further decreases from 0 to minus 1. Okay. After that it start increasing. Okay. That is as x increases from pi to 3 pi by 2, cos x increases from minus 1 to 0, but still negative in third quadrant. Okay. Now as x increases from 3 pi by 2 to 2 pi, cos x increases from 0 to 1. So cos x is positive in first and fourth quadrant, negative in second and third quadrant. Okay. Next, after sin and cos, next trigonometric function is tan x. Tan, as x increases from 0 to pi by 2, tan x increases from 0 to infinity. Okay. Tan x increases from 0 to infinity. So in first quadrant tan is positive. Okay. Now as x increases from pi by 2 to pi, in second quadrant as x increases from pi by 2 to pi, tan x increases from minus infinity to 0. Tan x increases from minus infinity to 0. So minus infinity to 0 means negative, no? So tan is negative in second quadrant, tan is negative in second quadrant, tan is negative in second quadrant. Okay. Now as you move further, that is in third quadrant, as x increases from pi to 3 pi by 2, tan x increases from 0 to infinity. Tan x increases from 0 to infinity, means 0 to infinity means positive, no? So tan is positive in third quadrant, Okay. Now as you move further in fourth quadrant, that is as x increases from 3 pi by 2 to 2 pi, tan x increases from minus infinity to 0. Minus infinity to 0 means minus infinity to 0 is negative. So tan is negative in fourth quadrant. Now if you observe here, tan is increases from 0 to infinity in first quadrant, increases from 0 to infinity in third quadrant. So tan is positive in first and third quadrant. Negative, tan increases from minus infinity to 0, minus infinity to 0 negative, and here also minus infinity to 0 negative, means tan is negative in second and fourth quadrant. Second and fourth quadrant. Okay, now up to here sine is positive in first and second quadrant, negative in third and fourth quadrant. Cos is positive in first and fourth quadrant, negative in second and third quadrant. Okay, tan is positive in first and third quadrant, negative in second and fourth quadrant. Okay, but next cosecant. Cosecant is reciprocal of sine. Reciprocal of sine. So whenever sine is positive, cosecant is also positive. Whenever sine is negative, cosecant is also negative. Okay, next. Now as x increases from 0 to pi by 2, sin x increases from 0 to 1. So its reciprocal decreases from infinity to 1. Decreases from infinity to 1. Decreases from infinity to 1. Okay. So in first quadrant, cosecant x decreases from infinity to 1. Okay, infinity to 1. Because cosecant 0 is undefined, cosecant pi by 2 is 1. So as x increases from 0 to pi by 2, cosecant x decreases from infinity to 1. Okay. Now further, in second quadrant, as x increases from pi by 2 to pi, cosecant pi by 2 is 1, cosecant pi is infinity. Cosecant pi is infinity, undefined. So in second quadrant, cosecant x increases from 1 to infinity. Okay, 1 to infinity. Now in first quadrant, cosecant x decreases from infinity to 1. In second quadrant, increases from 1 to infinity. Means in first and second quadrant, cosecant is positive. Okay. Now in third quadrant, as x increases from pi to 3 pi by 2, cosecant x increases from minus infinity to minus 1. Cosecant x increases from minus infinity to minus 1. Okay. Now further in fourth quadrant, as x increases from 3 pi by 2 to 2 pi, cosecant x decreases from minus infinity to minus 1 to minus infinity. Minus 1 to minus infinity. So in third quadrant and fourth quadrant, cosecant is minus infinity to minus 1, increases from minus infinity to minus 1. In fourth quadrant, decreases from minus 1 to minus infinity. Okay, so third and fourth cosecant is negative. So cosecant is positive in first and second quadrant, negative in third and fourth quadrant. Okay, next. Secant is reciprocal of cos. So wherever cos is positive, its reciprocal is also positive. Wherever cos is negative, its reciprocal is also negative. So as cos is positive in first and fourth quadrant, secant is also positive in first and fourth quadrant. Okay. Now secant x, as x increases from 0 to pi by 2 in first quadrant, secant x increases from 1 to infinity, because secant 0 is 1, secant pi by 2 is not defined, undefined quantity. So as x increases from 0 to pi by 2, secant x increases from 1 to infinity. Okay. Now in second quadrant, as x increases from pi by 2 to pi, secant x increases from minus infinity to minus 1. Okay. Now further in third quadrant, that is as x increases from pi to 3 pi by 2, secant x decreases from minus 1 to minus infinity. As x increases from pi to 3 pi by 2, secant x decreases from minus 1 to minus infinity. Okay. Next, in fourth quadrant, as x increases from 3 pi by 2 to 2 pi, secant x decreases from infinity to 1. So here secant is positive in first and fourth quadrant, negative in second and third quadrant. Okay. Next one, last trigonometric function, that is cot. Cot is a reciprocal of tan. So wherever tan is positive, cot is positive. Wherever tan is negative, cot is negative. As tan is positive in first and third quadrant, cot is also positive in first and third quadrant. Okay. As tan is negative in second and fourth quadrant, cot is also negative in second and fourth quadrant. Okay. Next. Now, as x increases from 0 to pi by 2 in first quadrant, cot x decreases from infinity to 0, because cot 0 is undefined and cot pi by 2 is 0. Okay. So cot is decreases from minus infinity to cot is decreases from infinity to 0 in first quadrant. That is, as x moves from 0 to pi by 2, cot x decreases from infinity to 0. Okay. Further, as you move in second quadrant, as x increases from pi by 2 to pi, as x increases from pi by 2 to pi, cot x decreases from 0 to minus infinity, decreases from 0 to minus infinity. Okay. Second quadrant, cot x decreases from 0 to minus infinity. Okay. Next, third quadrant, as x value increases from pi to 3 pi by 2, cot x decreases from infinity to 0. Cot x decreases from infinity to 0. Okay. Further, in fourth quadrant, as x increases from 3 pi by 2 to 2 pi, 3 pi by 2 to 2 pi, cot x decreases from 0 to minus infinity. Cot x decreases from 0 to minus infinity. Okay. Here what we have further, cot is positive in first and third quadrant, negative in second and fourth quadrant. Here in first and second quadrant, sign is positive, third quadrant and fourth quadrant, sign is negative. Similarly, cosecant also positive in first and second quadrant, negative in third and fourth quadrant. Okay. Cos is positive in first and fourth quadrant, negative in second and third quadrant. Similarly, secant is also positive in first and fourth quadrant, negative in second and third quadrant. Okay. Tan is positive in first and third quadrant, negative in second and fourth quadrant. Similarly, cot is positive in first and third quadrant, negative in second and fourth quadrant. If you observe, all trigonometric functions are positive in first quadrant. All trigonometric functions are positive in first quadrant. In second quadrant, sine and cosecant positive, remaining 4 negative. In third quadrant, tan and cot positive, remaining 4 trigonometric functions negative. Okay. In fourth quadrant, cos and secant positive, remaining 4 negative. Okay. We will conclude up to here. We will continue remaining topics in next class. Thank you.